In this video, we will briefly review scientific notation. The purpose of scientific notation is to express very large or very small numbers more conveniently, or more efficiently. Proper scientific notation is a constant that can be either positive or negative times 10 to the nth power. It's important to note that in this form, c must be greater than or equal to 1 and less than 10. So if c is not between 1 and 10, you do not have an expression written correctly in scientific notation. Write each of the following numbers in scientific notation. So let's take a look here at example A. Here we have 0.0000782. In order for this to be in scientific notation, we need to move our decimal to the right. And we need to do that 1, 2, 3, 4, 5 times until we get a number that is greater than or equal to 1 and less than 10. That number is going to be 7.82. Now we need our scientific notation part of the times 10 and our exponent. Notice to get from our new scientific notation back to the decimal, we're going to have to move that decimal to the left. That tells us that our exponent is negative. And it's negative 5 because we counted over 5 spaces. Let's take a look at example B. So in example B, we have 836,100,000. Notice that here our decimal would be at the end. And we need to move this decimal to the left so that we obtain a number that is between 1 and 10. So we'll move it 1, 2, 3, 4, 5, 6, 7, 8 times. So our new number in scientific notation becomes 8.36 1 times 10. And notice to get from our number in scientific notation back to decimal form, we get a larger number. So we will want our exponent to be positive 8. Our last example will be to write numbers in scientific notation and putting them into decimal notation. So let's take a look at example A. Here we have 9.36 times 10 to the negative 6th. Notice that that negative exponent is telling me that my decimal needs to move to the left, and this number 9.36 is going to get significantly smaller. So we'll write 936. Notice that our decimal is between the 9 and 3, and we need to move it to the left 6 spaces. So 1, 2, 3, 4, 5, 6, and this is where our new decimal will be. All of these empty spaces will be filled in with zeros. So our final answer here is 0.00000936. Let's take a look at example B. Here we have 1.345 times 10 to the second power. Notice here that because our exponent is positive, our decimal will be moving to the right. We have 1.345, and in order to move this to the right, we're going to move 2 spaces according to our exponent. So 1, 2, and our new number is going to be 134.5.